Today we'll look at how to create a temperature gradient through the shell thickness. Here we have a flat plate made out of aluminum, and that material is assigned to the CAD solid body. We'll be using that later to assign to our shell mesh. We'll start by creating our simulation files in the Nastran structural solver environment, and we'll create a linear static solution. We'll begin in the idealized part, getting an associative copy of the geometry that we can then mid-surface. Now that we have our mid-surface, let's go ahead and hide our solid body in our FEM, and we'll create our shell mesh. Now that we have our shell mesh, we can check our physical properties, and here I'm inheriting the material properties that we had assigned earlier to the CAD solid body. We're also inheriting the thickness from the mid-surface. Here we can see what that thickness is by plotting the thickness contours. Next we'll go to our sim, where we'll create some new load sets. Our first will be an initial stress-free temperature load set, where we'll define the default temperature, and then we'll create our temperature load temperature set. And in here we'll create our through thickness temperature load. And we have a couple of different methods that we can use. One is temperature and gradient, and the other is temperature top and bottom. Now the top and bottom temperature I'm putting in as a constant, but this could be put in as a field as well. And here I'm applying that temperature to the polygon face. Next we'll create some constraints. I'm going to be applying these constraints to polygon vertices. Our first will be a fixed translation constraint. Next we'll create a user-defined constraint where we'll fix the vertex in the Y and Z directions. And lastly we'll fix Z on the vertex diagonally across. Now we're ready to solve. And this one takes about a second to run, and we can look at our results. Here we can see the displacements reflect exactly what we would expect from putting a temperature gradient in the normal direction through the shells.